Ever wondered why customers suddenly leave a bank without a trace? Is it the service, the policies, or maybe the hidden patterns in their data? In this video, we are diving into the real world problems of customer churn, but not just with theories, nah. We are getting our hands dirty with a full machine learning classification project that actually predicts which customers are likely to say bye-bye to their bank. I'll guide you through everything from loading the data sets and preprocessing to training the model and evaluating the results. Whether you are a data science student, a fresher preparing for jobs, or just a curious coder, this project is your launchpad. So grab your chai, open your Jupyter Notebook, and let's decode churn like a data ninja. Let's go. In this video, we are going to start with this banking customer churn prediction. It is going to be a major classification project. Okay, in this we just have a data, okay, and we are going to take that data, we are going to perform cleaning things on it, we are going to utilize all the things which I have learned in our previous videos. Okay, so here which algorithm is going to be used, which model we are going to be using, we don't know anything. We just have to go step by step ahead, and with that we will understand the things. Okay, so in the end we are going to see all the things clearly. First, we will understand what is churn. Churn means whenever a customer stops using a product's services, like if anyone is selling any kind of product and that they are having customers, so one of the customers is going to stop, or if he will continue with that product, so like that we are going to predict. So with the basis of that, then we can increase or decrease our sales, right? So like that this works in every sector. Okay, that means this churn. Okay, so now let's not waste our time and we will start our tutorial. We will start a project. So let's begin by cleaning up the notebook environment. We are using warnings, filters to ignore them, okay, to keep our output clean and readable. This what it does, it avoids cluttering the notebook with non-critical warnings that Python might throw, especially from external libraries. Okay, nothing happened because whenever we are going to face any warning, that time this is going to be needed, right? So that is why we are creating this. We need this. Okay, just we are making sure that whenever we are working, we don't get any different kinds of warning, or there are things, right, exception, errors, like that. So first things what we need is we need a data set, we need some of the libraries to go with, right? The most common libraries which we have used up till now, we are going to import that. Okay, so we know for what these libraries are there, right? NumPy and Pandas, they are foundational libraries for data manipulation. Matplotlib, Seaborn for visualizations, right? And next what we are going to need, that is whenever we are going to need a library, we will come here in this import cell. I'll name it as import, okay, in the comment. Whenever we are going to import any of the library, we will come in this cell and we will import the things. Okay, so it will keep a track of the things. Okay, now next thing, what is there to begin with? We need a data, right? So let's take our data and then we will start working with it. Okay, so our first step is going to be, we have to understand what is there in that data. Now how we are taking any data? I am having a CSV file. You can take data in any form. Okay, I have downloaded it from Kaggle. So now as I told that I have downloaded, so it will be in my downloads folder. Okay, so again I'll press tab. I know where it is. Okay, so here my downloads is there, then this is there. Okay, so here I have loaded the data. Okay, this is the path in which my file is present. Okay, how we have did this, I have stored it in the variable named df. You have to remember this df. Okay, it is important, so I have to store it in this df. Now next is what is there in our data. Let's see that. For that what we can do is we can print or just execute this df. Okay, we can see this, we have 10,000 rows and 14 different columns. Okay, and this, but now I'm not going to do that. I'm going to df.head, sorry, and in that I have to pass the value. I'll just see what is there in the first 5 rows. Okay, so yeah, here you can see this df.head I have used. This is the thing that we are understanding our data. Okay, we have loaded our CSV file and we can see this is our things present with us. Okay, so what is there in that? This is the default one, right? It is indexed, it is given by the this notebook only, right? Then this row number is present. Row number, it is going to tell this, we can see that, right? It is simple. IDs, then customer IDs are being present over here. Okay, customer IDs, vnames, and surname is there. Is surname do we going to need that in the further? We'll discuss that. Okay, first we should understand what we want to predict. We want to predict that if the customer is going to leave that bank services or not, right? This thing we have to predict. So surname is not required, but still we will see further what is there in the data. Then credit score, if y'all are having credit cards or y'all are having any of the EMIs, loans on y'all, then you can understand what is this credit score, right? We need to maintain this credit score by paying our bills on times and all the things, right? Then geography means like where, location. Okay, where is this bank present? Okay, this surname, one person's bank is present in France. Okay, his gender or her gender is female. Okay, then age, what is the age? That is also being seen over here. Then tenure means year, for how many years they are using that bank services, like that it is a year. Okay, we can see that from here. Then balance, okay, the bank balance is also being seen over here. Number of products, now this is not required. Okay, then has credit card or not, this thing is also present. Okay, 0 and 1 you can see over here, right? Means like yes, no, yes, no, like that. Okay, it is not following the sequence. Okay, they are having or they are not having, like that it is present. Okay, the information is there. And if that person, if that customer is an active member in bank, means they are like depositing their money, or they are removing their money, or they are having the active communication or things with that bank, then is that member active or not, that is stored in this column. Okay, then their estimated salary, what is their salary of those customers, that is being stored in this. Okay, estimated salary. And then exceeded is our target. Okay, exceeded, why is it a target? Because it is telling in that, in this column, that if that person has left the bank or not. Okay, sample data is there, this is right. So this much data is present, means like 10,000 rows are there and this much is present, and from this we have to give like for training, testing, and then what are the next coming customers or the next rest of the data of the customers which is present with us. We have to predict on them that are they going to exit or not. Okay, like that. So some of the data, like if their female is there from France is there. Okay, her credit score like this much, then all the things of her, and then she has exceeded or not, like that it is present. Yes, 1 means yes and 0 means no. Okay, these things are clear, these things are there in that data, in a data. Okay, so these things are present, we need to understand our data very clearly, like we have to by heart that what is there in our data. So we have used this df.head. Okay, it is going to show us first 5 rows. So now we have understood our data, a basic opinion of our data, not opinion we will say, but basic idea of our data we are getting. Okay, what is there in our data and what we have to do in this, we have to predict this column. We have, this is a target. Okay, we have to remove this from this data. Okay, so this is going to be a target. Okay, now let's see what else we can understand from our data. Okay, what it is showing, df.shape, what it is telling us that there are 10,000 rows present and there are 14 columns in our data. Okay, it is going to give us shape of our data, like what is there. We can get this information from df.info also, right? Now we are inspecting the structure of the dataset using information. Okay, this gives us an overview of all the columns, their data types, and most importantly, how many non-null values are present. From this also we can clearly see that the exceeded column, which is our target also, okay, has some null values in it, right? And we need to fix that before any of the modeling or any further steps. Okay, even though we are having in the exceeded null values, okay, you can see this credit score also, it is also having some of the null values, right? You can see this, there are 9,998 values, and here Means here in exited there is one value that is null, and here in credit score there are two values which are null, right? We can see those things from this information. Okay, then from range index it is like 10,000. It is being indexed from 0 to 9,999, right? There are total 14 columns. You can see row number is there, it's integer type. Like how many float type of columns are there? We have 4 float type of columns. Integer we have 7, and object means like categorical values we have 3. Okay, memory usage, you can see this information we have got from information function. Okay, so now here we can clearly see what is there is null thing present in our target only. Okay, so we need to remove that or solve that. Like how are and what are the different types that we are using to remove null things or fill that null things? We have drop null, we are going to drop. If we want to fill it with, then we have mean, median, like that thing is there, right? With the average values we can fill. But here what we are going to do, we are not going to impute our target should never be imputed. You have to see like what is the factor, like how many values are there. If we remove that, then what major effect it is going to be, like that we have to see. Okay, now let's see which that person is there, which that row is there which is empty. Okay, and how we are going to find? We are having is null named function present with us, right? So we are going to use that, and we are going to see which is that row which is null in exited. Exited is our target, and in that 11th index is there. Okay, row number 12. Okay, that's customer ID is there, its surname is Andrews, his credit score is this much, he's from Spain. Okay, his male, his age is 24, from 3 years he's been using those banks services, and yes, he has credit cards. His no, he's not an active member, like that. So here we don't know that that person has left or not left a bank. Okay, so we cannot understand this thing clearly. So this is this exited column. Now what are the different approaches that we are going to use to solve this? If you have any ideas, you can comment. If you have any ideas, you can comment it. If no, then just pause, try to think, and then if not, then we will follow along. Okay, so what approach I am going to try, you will see. I am going to drop it. Okay, I'm simply going to drop it, because see, imputing the target is not a necessary step. And here now, as we are seeing which column, which row is there, okay, that is empty, we can see only one row, right? Only one single row is there, so we can drop it. We are having 10,000 rows to give to our machine. Okay, in that one row if we'll drop, then it's okay, it's not that major issue. Okay, so I'm going to drop. I'm not going to fill it with any null value or any other like default values or nothing like that. Okay, I'm not going to fill it. Now here also we can see what is the index, but I just wanted to print that separately, that index. So that is why by using this index function, index this I have sorted out the index of it. Okay, it's d type, like data type, you can see it is integer. Okay, now what we are going to do now, as I said, I'm going to simply drop it, right? So let's drop it. For that we have this drop named function, right? We are going to use, then in that for whom we are going to use it, for exited. So we have to mention that column, okay, its name, then what we want to drop in that null value, right? And where and how we are going to find that null value? For that we need to use this is null, right? Is null we are using, and then so what this df drop exited index and this access is doing. Access, what it is going to do, it is going to drop that row. If access would be 1, then it would have dropped the column. Okay, so this line removes those rows temporarily but doesn't modify the original data frame. Okay, and for that what we have to use is, we have to use in place equals to true, right? In place equals to true, what it is going to do, it is going to change the things in the original data. Okay, means in this file, this which we have loaded, in this file it is going to change the things when we are going to use in place equals to true. You can see this when we executed this, one row is missing, right? We were having 10,000 and 14 columns were there. Columns are there, but rows, you can see one is reduced, right? But when we are executing this null value, But when we are executing this null value again, this null cell things again, you can see this thing is present still, right? In this exceeded column, it is still in our data. So what do we do? So we are just going to take this only, okay? Or else what we can do is at this place only, we can just come over here, and now if we'll execute it, so we have executed this, okay? And now if we again execute this, we are not going to see any information, okay? Why this is happening? Because here we added this in place equals to true, right? Because of this, the things are being changed in the original data set only, in the original data frame only, and that is why we are not seeing these values over here also, okay? Now it is being completely deleted, okay, from the data frame. So that is why there is no use of this step also, right? Even though if we will execute this step again, okay, now let's print it over here and execute. You are going to not see any. We were seeing what? We were seeing this 11th, okay, because it was empty. But now as we have cleaned it, as we have dropped that value, we are not going to see. And we have also sorted the index also, means like 10, 11. You can also see that by, okay, just I'll cross this and df, and if you execute it, you can see its row numbers are being properly added, okay, 10, 11 and 12th one, right? We deleted that is why. And here you can see these things are present. Now here is the problem, right? 9, 10, where is that 11th one? Index range is being, right? It is not proper. For that, what we need now, as it is not proper, so what we will need is we will need to reset our index. It is our index, right? So we have set our data frame, right? We have given its names and means like drop that empty and all the things we did, okay? We have changed the things in the main data frame also. But when this index comes, it was pre-built, right? So we have to reset the indexes also. You can see this 10, and where is that 11th one, right? So we will reset index now. For that, what we are going to do now, from what we are going to resetting the index, we are going to, from our data set, right? We have this reset. Now see, there are many different functions present over here, but we need reset index, okay? Now why I am using this drop? Now as we have removed the rows, now our index numbers are also getting messed up. You can see this over here, right? 9, 10, and where is that 11 one, right? So like skipping numbers, right? It is being like skipping numbers. Our index is skipping the numbers. So what we are going to do? So we are going to use this reset index function, right? We reset them to make everything sequential again. And drop true, what it is doing, it is ensuring that old index doesn't get added as a new column, okay? This drop equals to true. Now this index is there, right? It is going to make the changes in this thing only. It is not going to add this reset this row, okay, this index column again as a new column, okay? We don't want that, right? It is not even needed, right? Why to take extra space? So that is why we have used this drop true, and in place true, you know what it is doing, right? Now so let's just take one last preview at our this. So you can see there are no null columns in, no null values in this exceeded, in this target, okay? How we are finding that? If in our data set, if in that exceeded column there is if there is any null value, then give me the count of that, okay? If you just remove this thing, you will see all the columns, okay? Everything it is telling us false only, okay? It means like in no any of the value there is not null, okay? In any row there is no null value, okay? If it would be have true over here, then we would have to check that again thing, okay? So it's simple, that just take sum only, right? We have learned these things also. What it is going, it is showing us 0, means like in that exceeded column there is no null value present, okay? So now as we were seeing in this info, right, in this info when we viewed things, we got to know that this credit score, it is also having null values, right? You can see its data type is float, and there are also some of the null values. So let's see how many null values are there, okay? this step we are going to, this only cell we are going to copy it, okay, we will paste it. So see, reusing the cell, we should understand how we are doing that. Okay, now we know what column was there, it was our credit score, right? So if we execute it, we just we know now in which column there is null value, right? We understood that. So I have just replaced the name of the column, and same thing is there. Okay, it is going to give me the rows in which null values are present. In credit score, see here there are two null values, so these two rows are there in which null values is there. Now what is going to be your approach? If you have any idea, you can tell me in the comments, but what I am having the idea, I'm going to use that. Okay, see, these are the index numbers of those rows, okay, those null values, okay, in the credit score. Okay, their row number, their customer IDs, their surnames, their credit scores, it is null only, right? The geography, one is Spain, one is in Spain and one is in France, right? Means like the banks are in Spain and France. Okay, then gender, okay, one is female, one is male, their ages is there, tenure is there. See, one is using bank services from 6 years and one is using from 3 years. Okay, see, bank balance is also there. Now okay, if we try to see the null values in the balance, is it going to be, means like, and drop them, so is it going to be fine? No, right? Because anyone can have their bank balance zero, right? If they are not using, they'll keep their bank balance zero. So that also things we need to understand. It is our work to understand our data properly. Okay, the number of products, has credit card or not, his active member or not, their salaries and their exceeded. You can see it is 1% it is being exceeded and 1% it is not. Okay, so now let's handle these two things. Okay, now what is your approach? You can tell me in the comments. You can try to solve it, but if not, then you can follow along with me. But here I'm not going to drop these rows. Okay, here I'll use a little bit different trick. What I'm going to use, majority wins, like that I'm going to do something. Okay, so what I'm going to do is, you can see this null values in credit score, we are solving those things, right? We have these two columns which we need to solve, right? Which we need to think some of the things and then to do with this null values. Okay, so what I have did is, what approach I am going to use is, first you can see that geography is Spain, right? Then their gender is female, right? And age is 43. So likewise, from all the data I'm going to collect the people, means like their geography is Spain, their gender is female and their age is 43. So like that, such kind of similar kind of people I'm going to choose. Okay, I'm going to see their credit score. Okay, and with the average or with the minimum, with the maximum value of those all similar kind of persons, I'm going to fill that value. This is a good approach, right? Take all of the average, means all employees or all customers average is not going to be fine, right? Not going to be a good approach, but taking just similar people's advice, that is going to be fine, right? We can relate to that things. But here when I used this geography, Spain, then gender, female, then age, these are common things. Okay, and how many records I'm getting? See, these many records I'm getting of those. So what if I add one more field in that? What if I add tenure also, means like if they are using the banking service from the 3 years only. Okay, similar to this I am taking the data. Okay, so I have added one more field, one more column, and let's see how many data. See, now this much, these 5 values I am getting, only these 5s. Okay, so taking the average or minimum, maximum, whatever, okay, things, if we take that thing of this, then we can get this value, right? A little bit of accurate, not proper that value, but bit of accurate value we will get, right? Now what this is doing, you can understand this. Okay, geography, gender, female and all this, tenure is there, but what I have did is, and credit score not null. Okay, not null, this credit score, these all four, rest of the 4 values. Okay, so this is the final filter we are going to apply. Okay, this final filter remove any rows that also have missing credit scores. Okay, so we can use just the valid data to compute an average. Okay, so here what I have did is, I have took this average, means this one variable name. Okay, and that I'm going to see, and now as I was having 2 rows in which empty values were there, right? So that is why this is the first average of these similar things, similar data. Okay, this average I'm going to take, and that I'm going to fill in that null one. Okay, So this is there, okay, this credit score not null, okay, I have dropped that. And then credit score dot mean means these four values mean I'm going to take, and then I'm going to fill it in that empty one first common which was there, which here this, in that I'm going to fill that value. Whatever the average is going to come of this, of these four values, okay, these four persons, that I'm going to fill, okay, and it is likely similar, right? That is why I'm going to take this thing. So let's execute this. So once we execute this, we are getting the mean value, okay. So now what we are going to do, we are going to directly fill that mean value, okay, to our index only, okay. And how we are going to get that, what index it was, we can see it, right, where it is, yes, this null value, okay. You can see this from here also, 4322, or else when we printed just those two rows, that also time we can see that, okay, 4322, okay. Just pass that value, 4322 it was, right, yeah. And then after that, what value we want to fill it over there, we want to fill the mean of it, right? So it is there, and where that mean is being stored, in this variable, okay. So just copy this variable and then you can paste it over here, because in this this mean value is present of all those columns, okay, of all these rows, right? Means like this, all these values mean is present in this variable CRAVG1, okay. And that I am going to give to this index, I am going in this index I am going to fill that average value, okay. So let's execute this, and then if you will print this again, where is that step in which I have printed this too, yes. If you will execute this step again, what you will see, just let's see, we can see just one value, because this one is being filled. Now there is no empty value over there, right? But that is why we can see just one value. And if you want to see like what value is being filled over there, then you can see it by df from data log, okay, and then put the value. Now we know at what value, 4322, right? It was this value, right? And then what is the value we want to see, okay. So just execute this, all the record of this index number, it is going to be seen over here, okay. Whatever the values are there of this index, we can see all the values. Its row number is this much, this, and what was empty, it was credit score was empty, right? It is being filled with this value, okay. Average of all these four rows, okay, it is this much, and it is being filled by this value, okay. So our credit score is no longer empty, right? We are going to use same technique which we used for this first row, okay. We were having two values empty, right? The second is also there, okay. You're going to follow the same steps and you're going to do the same thing with this also, okay. And then in that way we are going to remove that row also, okay. Means not going to remove, we are going to impute that row, right? This is null sum, okay. This is a super handy command that I always use. It gives us a common column wise breakdown of all missing values in the dataset. And right now, as we were focused on the credit score, we are seeing this one more value is there, right? One more row is there which is to be removed, right? Which is to be impute. So what is the common things which is present in that? Let's see. See, here we can see its row number, it is going to be common, right? Its ID is also be going to common, surnames are not going to be same, okay. Credit code we have to say. So we will choose this geography, we will choose their gender, their age, their tenure, balance not, okay. Then anything, salaries cannot be common, right? So let's take these things and then we will again sort the things from the data, okay. So when I took the similar things like geography, France, okay, means like a bank is located in the France, then male, gender, and then age, okay. I have took just these things, okay. So I've got this much record. I can take the values, right? If I feel, or should we add one more field to it? Okay, we can take the average of these values, right? So we'll keep this. We are not going to add any one of the field again. So now perfect, okay. This line filters the valid rows matching our profile and takes the mean credit score. That's what we'll use for our final imputation, okay. So what we did before, we are going to do same thing. We are going to store it in one variable and then we are going to impute it in the next value, okay. means next not mean this null value. Okay, we need to drop this, not drop this, we need to remove this from here, then we need to remove the mean of it, and then we need to store it in our this one. Okay, this particular block. So with this we fill the last missing credit score using the average of similar customers, right? This is a smart imputation done manually, far better than dropping or just using just a global mean, right? If you again check if there are null values, then you can see there are no null values present. Okay, and mission accomplished, no missing values left. Our dataset is now clean for next steps. Now next up, what we are going to do is we are going to take a deeper look into a target column, that is exceeded, right? Our target is there. I'll write it in the comment only. To be balanced. So when we execute this column, this cell, okay, from our exceeded from our target, value counts what it is going to give, means how many have been stayed and how many have churned. Okay, so like that this is going to give us the count. Okay, so it's an important check. We want a target classes like churned and stayed, churned versus stayed, to be balanced. A good balance is ideally like 50-50 or at worst like 60-40 maybe. Okay, if it's super skewed, we'll need to handle it using techniques like SMART or class weights, etc. So now this was for exceeded. Now let's see for other columns also, other fields also. Okay, checking the distribution of has credit card or not. Okay, it is also an important feature. It tells us how many customers have credit cards. It is good for us to know while doing EDA, okay, and feature selections. So same idea. This one tells us how many customers are actively using the bank's services. It is important for churn analysis. Okay, for number of products. Okay, number of products, how many products are there in total? There are, means like if unique we need to find out, there are 4, and then value of this. Okay, so and here's the number of products each customer has with the bank, like 1, 2, 3 or even 4, right? This might be a strong feature when we predict churn later on. Okay, now let's understand our data a little bit more. Time for a bird's eye view. Describe gives you statistics for numerical columns like mean, max, median and standard deviation. Okay, adding T means like transposes the results to make it easier to read. Look for outliers and column ranges here. Now let's hunt for the outliers. Okay, these outliers are extreme values that can really mess our models, especially in algorithms like KNN or SVM. Okay, if we need to use those algorithms, then we need to handle these outliers also. How we are finding the outliers, you know, okay, most of the things. Okay, now here as we have just printed this described to you, okay, you can just go through it. Okay, we'll just quickly check row numbers, how many rows were there. We have deleted one row, right, when we were working with that exceeded net value. So we know how many rows are there. Okay, how many rows are present in our data. Okay, mean values of those. Okay, mean values have been calculated, so it's okay. Standard deviations are there. Okay, minimum values. Now here you can see row number, minimum value. Okay, it might be 1, it is good. Okay, then ID, the first one ID it would be, right, the minimum ID of the person, customer's ID, right? Then credit score, okay, 350, that is also fine. Okay, then age, you can see the age, minimum age over here is 1. Is it even possible? No, right? So here there is some of the mistake, right? So we need to find this, we need to sort this thing, right? So age is minimum. Okay, that we need to clarify. Okay, then tenure, okay, fine. Balance, minimum balance is 0. Okay, then tenure, why I'm saying 0, because there might be the persons, there might be the customers who have newly joined the bank, right? So we can consider that possible outcome also. Okay, number of products, we have seen how many products were there. Okay, these many, up till now these many products one person or one customer was carrying. Okay, then has credit card, okay, fine, the min value, max value, active member, salaries. Okay, you can see this min salary over here, it is 11 rupees. Is it even possible that any one person who is working, who is earning person, and he's getting 11 rupees salary? No, right? So that also we need to keep an eye on it. Okay, we need to check that thing also. And exceeded, we have almost worked on this exceeded, so there's no problem because we need to find these things only, right? So min column you have checked, okay, 25%, you can see all the things like this. You have to understand by describe, okay, you can understand your data by describe. We are thinking that we have first only viewed our data when we were just loaded our data. No, it's not like that. We need to understand our data, we need to keep learning about our data, the things, okay. Now here we have understood that age cannot be this much, salary cannot be this much, right? These things are too weird, right, to here also. Then 50% of data you can see over here, 75% maximum, you can see maximum row number is 10,000. Okay, we'll take it into consideration, okay, for now. Then credit score, then age you can see 92 is there. Okay, fine, that might be the thing, okay. Then balance, okay, you know, minimum balance was 0 and you can see the maximum balance, so it is also a thing that we need to keep an eye. Number of products 4, fine, okay. Has credit card, is active member, okay. Estimated salary also if you'll see, then okay, fine, we'll take for right now, we'll take it as fine, okay. So these are the things we have understood from our data, right? Here when we have come up till now here, okay, we know what our target is, right? Based on that, okay, we can understand like, is customer ID required for it? Is okay, customer ID we will keep, fine, okay. Is the credit score required? Is the age required? Tenure is required? If they have credit card or not, this field is required. Are they active member or not? These fields are required. Are these really required? If you think carefully, then no. Some of the fields from this are not required. The main fields which we are requiring, that only I will take now, okay. So after analyzing this, we understand that there are many things which we need to work on, right? So first thing which we are going to work on now, that is outliers. We are going to handle outliers. So for handling outliers, what I have did is, the fields which are important, I have took those in this one variable, okay. Means like, see, we understand this row number is just not needed for the prediction of this exceeded, okay. So customer ID is also not. So like that we discussed like which fields are required, which fields are not. So I feel these 4 important fields are required for my predictions, so I'm going to take this, okay. In that age, we saw we were having minimum age 1 and maximum age was 92, right? Here also you can see that, right, in this describe. So these things are something like which we can't believe or which we can't trust, right? So we need to see those things, and those we are considering as outliers. So to visualize outliers, the best thing, that is box plot, okay. So we have printed this box plot over here for age, okay. We are right now working on this age one, okay. We are going to handle the age fields outliers, okay. So I have printed just box plot of that age, okay. From that I can understand that these outliers, okay, this is minima and this is maxima. Anything that lies between minima and maxima is okay. They are within the normal range, okay, but anything outside them is known as outliers. So these are the minimum one outliers and these are the maximum one outliers, okay. So what I have did is I have created a list, okay. In that list all it is going to be stored, okay. For outliers, to solve outliers, there are many different ways we know, right? The one which we are going to use, that is IQR. IQR means interquartile range, okay. What happens in that, it is having its formula, okay. But what we need to do is we need to separate the data into different parts, okay, into different quarters. That is, I have separated into Q1, Q2 and Q3, and the formula is also of IQR, that is Q3 minus Q1, okay. So in Q1 25 percentile of data will be there. In Q2 of course it is going to be 50%, and also Q2 means this line, this is known as median, okay. So it is the middle point, it is the median, so of course 50 percentile is going to be separated at that, okay. In Q3 it is 75, okay, this is a Q3, okay. The rest of the data, 75% of data is going to be in this, okay. So that's how we have separated our data into Q1, Q2, Q3 into 3 different quartiles, okay. IQR formula is there, that is interquartile ranges formula is there, Q3 minus Q1, third quartile minus Q1 quartile, okay. That is the formula. Here minimum what it is going to be, for minimum what formula is there, we have to minus with the 1.5 and multiply it with IQR. Okay, this formula is there, this is separated things. Okay, and this is the formula for that. Then for maximum it is this. Okay, we have to add with 1.5 and then multiply with IQR. Okay, means this is going to give us the values of these ranges. Okay, these values we are going to get, and with this formula, that is Q1 minus 1.5, this formula, this minimum, we are going to get this value. Okay, so you can see the minimum value, it has given me 14, and the rest of the things which are beyond 14 or below 14, those are considered as outliers, right? And in this describe, we saw that age was, minimum age was 1, so this 1 is being considered as outlier. Okay, and maximum is 62. Okay, above 62, anything that will come, means anyone's age, if it is above 62, then it is being considered as outlier. Okay, this is the range we have given. Now anything beyond this, beyond these two values, anything, we are going to store that in a list. Okay, for that we have created this function. Okay, anything, see, you can see this formula is there, Q3 plus 1, this one was giving us this values. Okay, so these values, we have took these values and this value, okay, these outliers value, and we have created a list of it, and we are storing it in that. Okay, so these many other outputs which we have got, which we have stored in one list. Okay, so these many other, you will see all the values above 62 and less than 14. Okay, so we have got those values. So these are those rows. Okay, these are those values, means in outlier range what are the different values, we are getting the full records of them. Okay, these are the different, so in all we are having 360 rows search. Okay, and 14 columns, we know this thing, right? But I mean, we have segregated this all rows, these 360 rows, with the help of this age column. Okay, so every person's age in this 360 rows values in this columns and rows, it is above 62 or below 14, their ages are. Okay, so with the age we have separated these values. Now next thing is how to handle these outliers. What we can do, we are not going to drop all those rows, right? Is it a good, do we have a good reason? No. Do we have any value to impute or fill within that thing? No. And ages we can't fill with minimum age or maximum, mean age or like that, standard deviation, variance, all those things, means we cannot impute the age, right? How can we impute the age? Age is different of every person. It is not the thing that we should predict, or we can predict, right? Age might be anything. So what we are going to do is, we cannot delete it, we cannot impute it. What are the other things that you are using to handle outliers? You can tell me in the comments. Okay, but what I am going to do is, I am going to see the relation of all these age columns, this age blocks. Do they have any relation with my target? That I am going to check. If they are affecting target, see, we want to predict this exceeded, right? If the person is churned or not, right? So if age is affecting that, then we need to look at this age outlier, right? But, and these are 360 rows, it's not a joke, right? We need to think properly. So, but if it is not having any kind of connection between, then why to keep? If one is not related to other, then what is the reason, like why these rows are important, right? Because the main focus is on this exceeded, right? So what we have to do is, we have to check that if there are any trend, if there is any relation between this age and exceeded, means like if age is 66 and it is exceeding only, or if age is any other thing, then it is staying only. Is it like that? You can see 66 is there, then 1 is there, 75, 65, means is there any specific trend following in this exceeded? No, it is not. That is the reason what we are going to do is, we are going to remove these 360 rows, these all outlier values we are going to remove, because they are not having any relation with the exceeded column, and we don't need that thing then. Now here I have dropped these outliers. Okay, if you want to check, or if we can check, then how we are going to check? We can just do that describe again, right? So how we are doing that? Now you can see in the age the minimum value is 18, okay, and in the maximum it is 62, right? So we can understand with this also that our outliers in the age column are being handled, okay. So now, as when we created that multiple colds, right, this variable we created, in that we took these 4 different fields, right? So we have handled the outliers of just age. So now we are going to move for this credit score, okay. So I'm going to copy this thing, this box plot, okay. It gives us nice visualization so we can understand the things, right? So I'll create here one markdown and I'll write here as credit score, okay. Here I'll print this this cell, and here I'm just going to change the name to credit score, okay. So it is going to give me all the outliers present which are in the credit score, okay. So here you can see above the maxima there is no outlier, and below the minima there are some of the outliers, okay. So let's see what these outliers are and how we are going to handle these outliers. We are going to apply same things, okay. Here we made visualization first, okay, then we created a list, we separated the data into q1, q2, q3, right? We applied the formula, we found minimum, maximum, what are the outliers, right? And then we created this function a little bit, sorry, not function, we created this loop and then checked if they are having any trend or they are having any relation with the with our target, and if not then we have deleted it, if yes then we are keeping them, okay. But let's see how many are there. Here they were 360 and it was okay to delete them, okay. So we will see if they are less then we can delete it directly also, but we should check, okay. So now the same things we have repeated for the credit score also, okay. Here new IQR range we have given, okay, and thresholds also, and it's super semantic, okay. We just have to plug it the new column and we have to repeat the things, okay. Simple things are there, just same that, then again that loop, okay. So we got these values which are considered as outliers, okay, in credit score, means these values are considered as outliers in the credit score, okay. So what I have did is I have printed those rows in which these values are there. I have just printed those rows, okay. First is list and then I have printed all the values which are considered as outliers in the credit score, okay. So how many values I'm getting, you can see this, okay. So now we have to investigate these rows, right, and transform them or remove them. Let's see what is that trend with the exited, okay, if they are following any trend. By looking at the exited only we can see yes they are following a trend, okay. Every outlier, okay, is there, and then in exited we can see that yes they are churned. So we are not going to delete this, okay. Let's see if we can impute or not, or rest of the things, okay. But I'll suggest that these are not much values, okay, and they are showing relationships, so we are not going to change anything with these outliers, okay. We are going to keep these things as it is only. We are going to let these outliers be in our data, okay. But we know that in our credit score we have got outliers, okay. Let's see what it is going to give us ahead, and if it is needed then we'll come again to this credit score and we will then see what we can do with this credit score, okay. Right now we are going to move because they are not too many values, okay. As like in age we were having 360 values, but here they are not too many, okay. So that is why. And this thing we are going to understand when we are going to view our classification reports, okay. So that is why we need to first see what our data is going to give. We need to clean up the things and then we are going to move choosing the model, and then when our results come, when our classification report comes, that time we are going to go with one of the report, one of the model, and then we're going to keep it like that, okay. So next what we were having after this credit score, I think we were having estimated salary, or what it was, let's see, too many things, right? Yeah, so yes, it is balance and then estimated salary, okay. So same things we are going to do with this estimated salary and this balance also, okay. So follow the steps and you can show me if you are doing it before me, or else what are your suggestions, you can mention it in the comments, okay. So for balance, same IQR process, okay? And one cool thing you can view is that balance might often have zeros. So expect some skewness or clustering here, okay? But here also, if you just use that same functions and same list and all those things, okay, and then same loop, okay, you will understand the things. Here the minimum value, we are getting it into the negative one, okay. So if we make visualization of this, we can see that our data is little bit skewed, okay. We can see the skewness in the data. We will with these things also, okay, we'll understand there also, but maximum it is okay, but we are getting the value in negative, so that might be the reason that our data is skewed, okay. We need to check these things, but here right now there is no outlier, okay, means it is giving us the values, okay. Then whatever the rest of the values are there, we have created a loop for that, okay. And here you can see that it is showing none of the value, means that it is telling us that there is no outlier, no any value is there which is beyond these values, okay. Let's make visualization of this also. We just have to take this and then we will create a cell above it and just paste it, change this to balance, our field name, okay. If we visualize, you can see there are no outliers, okay. Minimize also here only, we need to look at things properly, okay. If we increase its shape also, then also we will get the same thing only, okay. It is being clearly viewed now. So right now it is not showing any outlier, but we can understand because negative is there, okay, it is a bit skewed data, okay. You will see when we make visualization, and if we see the rows in which that outliers are there, as it is no, so it is showing us empty things, okay. It is not showing us any row in which outlier is present with, if we sort the things with the balance, okay. So now what we will do is we will just copy this, and I think we have copied that also, but here I'll write as, here also we are not getting any outlier, right? How good it feels to look like this, right? How these visualizations are giving us this tiny little happiness, okay. But still we will go with this process, okay. We will just confirm it once, not but just with visualization also we can understand the thing, but still we will go with this also, okay. Because when we viewed these things, when we executed this cell, when we created those things, okay, means like separated the data into q1, q2, q3 and then followed that formula, okay, we got this answers, right? And with this we can understand that our data is a bit skewed, okay. So that is why we will go with this also, okay. So now as we were seeing this visualization also, that also we understood the things, right? But still we have followed the things. Here also you can see it is in negative, okay. So we are going to make visualizations next, okay. In that we will understand the things in better way, okay. So here what I have did, I have repeated the same process, and here also I have not got any outlier, okay. When I printed the rows of it, then also I didn't got any row, okay, as there is no outlier, so I didn't got any row of it, okay. So we here what we did is we handled the outliers in age, we handled the outliers in credit score also, not handled, but we are going to keep as it is because they are not many values, right? So with the minimum visualization, this box plot which is for outliers, how it is showing us outliers, we can understand the things right now very clearly, okay. So what is going to be a next thing? With outliers handled and data clean, it's time to shift gears. Let's visualize the data and find relationship between features. Quick type check. Before plotting or encoding, we need to know which columns are numeric and which are categorical. This helps us decide the right types of plots and transformation. Just listing all columns. Sometimes handy when you are working in Jupyter or building loops to iterate through columns for visualization or encoding. Now we are revisiting the top few rows because probably to refresh our memory or prepare for visualization loop. It's always a good idea to do a sanity check. Let's start with some visual fun. A count plot shows how many males and females are in the dataset. It's a great way to get an instant snapshot of gender distribution among your customers. Notice any imbalance? That could be an interesting lead, right? Now we are going to make the count plot for geography also, okay? What I'm going to do is I'm just going to copy this thing, okay? It's simple, right? Just paste it, and here you have to change it to geography. Okay, I'll copy the geography word also. See, because what happens, it is case sensitive and I don't want to get any error. So that is why I'm doing this thing. So you can see in this count plot, we are having our banks in France, Spain and Germany. Okay, it's like geography, three different types of geographies are there. Okay, you can see in which there are more customers. In France we have most of the customers. Okay, in Germany then next, and then in Spain. Okay, so like that, within that female and male, how many male are there? In most of our customers are male and less female are there. Okay, we can see the count also of it. Okay, with this count plot you can answer the question like, where are your customers from, right? It is going to reveal the geographic distribution, like how many are from France, how many are from Germany, how many are from Spain, right? If you are planning any region based marketing like that, then you can get a lot of information from this visualization, right? So yes, if they have credit cards or not, how many are there who has credit cards and how many are there who don't have credit cards, you can see this thing also from here, right? What it is showing us, it shows us how many people have credit card versus how many don't, right? It's a binary column of 1 and 0. 1 means here yes they have, and 0 means that is no. This kind of data is gold for segmentation and modeling. Okay, you know what segmentation is, what is modeling also. Now we are going to plot it for if they are active members or not. Okay, so how many users are active members? Again, it's binary. These type of plots are simple but powerful and help us to understand users' engagement at a glance, right? Now one last count plot we are going to plot. It will be for a target column. Okay. Now we hit the heart of the problem, churn. The exited column shows whether a customer left a bank or stayed. This is your target variable for churn prediction later, and you have to look for the imbalance here too. If you want to see how age is distributed, a histogram helps. This tells you which age groups dominate your customer base. Watch for spikes. Most customer in their 30s, 40s. This guides product targeting. Okay. Same histogram we are going to predict for credit score also. This credit score tells us about financial health. A nice, smooth histogram helps us see if people are generally low, medium, high scorers. Any sharp drops or clusters, investigate it further. In credit score, when we were handling outliers, we told that our data might be skewed, right? Here also, if you focus on it, you will understand the thing that why I said that data is skewed, okay? And which side it is skewed, it is right or left, just comment it. You can see only everything is going okay and this one bar is high. So why it is, you can understand the things now better, okay? That's expected in banking data sets, but high balances are worth watching. Maybe those customers needs VIP treatment, right? Estimated salary shows income spread. It might be flat or right skewed. Combine this with balance and you can do wealth profiling or tiered marketing. So, okay team, it's time to go deeper. We are going to start exploring how different variables relate to churn. This is where we start spotting patterns that explain why customers are leaving. So what I have did over here is I have created a box plot, okay, as we are going to compare the things with our target. So yes, target is going to be in every that four important fields which were there. There were age, age was there, then estimated salary, balance and credit score. These four were important, right? We are going to keep these for this prediction of exceeded, right? And then what I have did is I have given title that age versus exceeded and then show, okay? So you can see in which there are outliers, okay? This is so useful, right? A box plot showing how age differs for customers who stayed versus left. Older customers might be churning more. Is that the case here? Next I'm going to check for balance, okay? Are people with higher balances churning more or less? Sometimes wealthy users feel ignored and leave, right? This chart helps us detect that. Next we are going to see with the estimated salary, okay? Do high earners stick around or leave? These box plots reveal the central tendencies and spread. Super valuable for segmentation. So these things we have plotted, okay. We are not going to plot the credit score, okay. With these box plot also you are getting most of the information, okay. These, if they are having any relation with exceeded or not, okay, that we can see, right. Age was not having, okay, age was on his road and exited was on his road, right. It was not having any trade, and credit score, of course, it is going to have, okay. We have understood that before only. Now next we are going to see the count plots, okay. Count plots connected with the this exited one, okay, churned one. Geography versus exceeded or churn, you can see. Perfect for region-wise analysis. This helps you know if customers in one country are churning more, maybe they need better service or local offers, okay. Then next was with this gender, we this visualize the thing. Then next with geography, okay, with geography you can see these things, okay. Geography and how many from that are leaving the services, okay, leaving the bank. In Germany there are most of the peoples who are living, okay, so we need to focus in this region, okay. Geography wise churn it is. Then for active members, if they are active members or not, like that, okay. This we can understand with our basic knowledge also, okay, is with our general knowledge also. The next is if they have credit card or not, okay. If having credit card is having any connection with leaving the bank or not, is not like any logic is there, okay, with that. So these all are the count plots which we have visualized, okay. Simple, okay, there is no difficult thing to understand in this, okay. We have got most of the information with this visualizations. So all right, now we visualize the heck of this data set. Now it's trying to prepare it for machine learning, feature encoding, scaling and splitting incoming. So as we have seen every prediction or every important fields with our churn, with our exited column, okay, we have compared those things. What I felt is when we just printed this, okay, df dot head, oops, you can see this customer ID, surname, okay, row number, these are not needed. So what I'm going to do is I'm going to drop these things, okay. For my further analysis I'm going to drop these things. So now if I'll see my data, or else I'll just copy this, come here, paste it and execute it. Now my data is a little bit less, okay. You can see this thing also, that row number, customer ID, these things were not necessary, so they are not here. In credit score, geography, gender, age, tenure, balance, these things are there, and these many things only I am keeping over here, okay. So is it clear that why we are taking these fields? Because the number of data which it is less, if the number of fields are less, we can understand better. So now here we need to work on some of the categorical values also, okay, categorical data also. For that I have created this, okay. I am going to make visualization only, next visualization it is going to be, but here what I have did is I have already mentioned the colors, okay. I have created this colors named variable, okay. In that I have given this 4 type of colors, okay. You will understand this when we have predefined the things, okay, means the common things which are going to be in any of the visualization, that we have predefined it here only, okay. So we will just access one variable and then all the things will get, okay. This is a common cell, okay, I have created. I have used this, or I am going to use this in many of the visualizations, okay. So if we'll execute, you can see these things, that labels, title, labels and all this, limp and all these things are common, okay. Why this limp is there, you will understand when you will see the visualization. These some of the description about that visualization I have mentioned, okay. It is simple visualization only, simple count plot is there, okay, but I have made it a little bit advanced, okay. Distribution of exceeded column, okay, with retained and statements, in that only 0 and 1, okay. I have just created this simple count plot. It is same as like if we have created over here or not. One single variable was there, these are compared ones, right here, these are single ones. So we have created this distribution of age, if it is active member, has credit card and all that, geography, the gender. No, we have not created this, but you can see this thing, this simple one visualization only it is there, okay. This simple count plot is only there, but it is for exited column and it is I have created a bit advanced. Okay, you can see the colors, you can see their percentage, you can see right all the thing present over here. That is because just I have created this loop in it. Okay, just simple, this much only is needed. Okay, this with this also we could have got the information. So now what I have did is all the categorical values I want to find. Okay, number of products and credit card, these are okay, these are numerical, but this gender, this geography, these are all in categorical, right? So I'm going to separate those things. Okay, as machine cannot understand the categorical things, right? So we need to do that. Here just simple histogram is going to be there. Okay, its size I have mentioned, bins, layout, color is going to be edge color, what it is going to be black, and line width is going to be 1.0. Simple histogram is there, but I have given a little bit of description for it. Okay, so I have created that, and it is for multiple cols. Multiple cols was a variable for 4 different fields, right? So we are going to get 4 different fields histogram. Age, credit score, estimated salary was there, and balance was there. Okay, so we have got this thing. You can see in age, when we were working with the age, we handled the outliers of age, right? So it is a bit okay. You can see this with the help of this. In credit score, we left those outliers as it is, right? Because they were having a relation with our target, right? So there it is going to be like this only. Then next was balance. In balance, we didn't got any outliers, but we saw that we got the values in negative. That I told that our data might be skewed. Okay, one side our data is too much. Okay, it is bent in one side. You can see the single bar is standing outside. Okay, and if this much data you can see, it is okay, but this one bar is making difference, right? And when estimated salary was there, there was no outlier, there was no anything present. Okay, and we get this visualization with the outlier. Okay, this histogram. Okay, you can now understand these details, what is there in the x-axis, y-axis. Okay, these are simple things. Okay, and for estimated salary, you can see the things by yourself only now. Okay, we now understand most of the visualization, how to read the visualizations. Okay, so that now I'm not going to go in depth with this visualizations. Okay, we need to go a long way ahead. So multi correlations, as I told that we can compute the standard correlation. What we can do is we can compute the standard correlation coefficient between every pair of features using pandas correlation method. Okay, and that I have created over here. For here it is going to be this things, and for this only I have printed a heat map. Okay, heat map, its description I have given, and here is that heat map. Okay, if you find the correlation very high, between like -1 to -7 or 7 to 1, then remove one of those correlated values. Okay, or the variables. Okay, you can see this thing, heat map is there. Okay, everything is in front of you. And with this visualization, we can understand that there is no significant intercorrelation between our features. So we don't have to worry about multicollinearity. Now what multicollinearity is there? You all know that. So now after heat map, what I have did is I have created a common function. Okay, with which we are going to understand those features in more depth. Okay, this heat map and this all things, they have given us enough of information, but still we'll need to understand some of the things, because more the visualization, more the hidden depths are being going to found. Okay, more insights are being found. Okay, if we create. So here also I have created, this is the common one loop I have created. Okay, for histogram, it is all going to be histogram as well as box plot. Okay, so we are going to have box plot also, histogram also in one only. Okay, I have mentioned some of the description for them, and then what data is there. Okay, that I have passed. So first I have plotted for age. Okay, age you can understand from here also. You can see what color is for retained. Retained means, so the outliers or the box plot for just for churn people is also here, and for the retained people is also here. Retained means those are using, those are stayed. Okay, for them. Then for credit score, we have the same, this box plot as well as this histogram also. Okay, you can see the information of them also with this. You can see that the persons who have stayed, it is a little bit of left skewed, right? So those things are also there, the accounts you can see, right? And this people's also you can see the graph. Okay, then their box plot you can see. Next is for balance also I have created the same balance also. You can see the thing that it is a separate bar is there, right, which these all information we have seen here also. Okay, everything that is present over here, that is only the thing which we have printed over here also. But what different thing can you understand by these things, you have to mention it in the comments. Okay, for estimated salary also the same thing is there. Okay, you can see how the visualization is, right. Most of the things we have seen in a previous visualizations also. Okay, but what happens is whenever we are creating visualizations, it may happen that we might understand more things. Okay, some of the hidden depths also we can get, so that is why we are creating more visualizations, possible visualizations we are creating. Okay, now next what we are going to do is we are going to work with the categorical values. Okay, there are some of the categorical values and which we need to convert into numerical, because machine don't understand categorical or the text forms, right. Machine is not going to understand, machine only knows binary language, right, zeros, one and numbers language. So that is why we are going to convert it. Okay, for that this is the predefined things, okay, which I am going to mention, because and I am going to use these things further. Okay, this is the common type which for all the cells I am going to use. Okay, I have mentioned colors first only, what colors I am going to need. Okay, and you will understand this thing when we will go further. Okay, so what I have did is categorical is variable, okay, which we have created first only, in that these much values are there, these fields are there. Okay, but we know that has credit card, it is not a categorical value, number of products it is not, but there are some of the fields. Okay, but these are the fields which we are using up till now. Okay, rest of them like some of them we have deleted. Okay, from here also if there is need then we might delete using these fields. Okay, I am going to create some of the things. It is going to be a common loop. Okay, common loop, and with this also you can understand there are going to be subplots. Okay, subplots, and you can understand the count and geography. Okay, for each field I have created this, and the categorical value or the categorical field which was like geography. Okay, in geography we have these many. Okay, the count has been given. For gender it is, for tenure it is in years. Okay, so that is also not not a problem for us. Okay, number of products is also okay, and has credit card is also okay. If it is active member or not, that is also okay, but you can understand these visualizations better. Okay, in tenure there are more colors, right, and these colors which I have mentioned over here only, right, color category I wanted is, so this I have mentioned. Okay, and using that it has created this subplots. Now what these subplots are there, we are familiar with it. Okay, why these subplots are there and the necessary things for those subplots have been mentioned over here. Okay, and by watching these visualizations, what the information are we getting? We are getting that the bank has customers in 3 countries, right. We know those countries, France, Spain and Germany, right, and most of the customers are in which country? They are in France. And there are more male customers. With this visualization what do we get? We get that there are more male customers, okay, than female. And what do we get next? Only a small percentage leaves within the first year. The count of customers in tenure years between 1 and 9 is almost the same, right. We can see those things with our eyes. Most of the customers has purchased 1 or 2 products, while a small portion has purchased 3 or 4, right. This also we can understand with the help of visualization. And the significant majority of the customers has credit card. Okay, and almost 50% of customers are not active. This is also the thing that we have understood from these visualizations. Okay, now what we are going to do is we are going to look at these features again in great detail. Okay, so here we are going to understand these things in more depth, right. For that I have created the same things. Okay, multiple visualizations in one thing. Okay, so that thing for geography we are going to go with. Okay, here same things are there, but what we have did is we have added one more field. Okay, so by looking at this visualization what do we understand? Okay, we can understand the things like there are 2 visualizations but with different fields. Okay, so what do we understand with this visualization? That customers in Germany are more likely to churn or exit than the customers in the other 2 countries, right. The churn rate is almost double compared to Spain and France, right, and many reasons could explain this finding, such as higher competition or different preferences for Germany customers, right. We can understand this thing with these 2 visualizations. Same goes for this gender. What do we understand with this gender? By looking at this, say female their rate, means churn rate and retained rate, means are they leaving the bank or they are using the services of the bank. Okay, we can understand with this for the females and for the males. Okay, we have got this thing. From here we know that there are more male customers, right? And here what do we get? Gender, female and male. More female are, this is the churn rate, right? More female are leaving the banks. Okay, so this thing we get from this visualization. It means that, in short, what do we get from this chart? That is, female customers are more likely to churn. And for tenure, what do we get information from this visualizations? The churn rate of it is not having any effect on the churn rate, right? That we get from this tenure charts. Okay, and number of products, what do we get from number of products? The churn rate. Okay, and for this has credit card and this active member. Now y'all are going to tell me these things, that what the information we get from these visualizations. Okay, you are going to mention it in the comments now. Now next what we are going to do is we are going to drop some of the more features. Okay, some features like their salary, I don't want their salary. Okay, so like that there are more features which I don't think that they are important for my target. Okay, for my target prediction. So features to drop like tenure, years. Okay, how many years they are using those bank services, that is also not needed for me. Okay, then if they have credit card or not, these things I am going to drop. Okay, so okay, I have dropped those things, but what are they being really dropped from a data frame? We need to check that. Okay, and only the rows are being removed over columns, like that also we have to check. And for that what we can do is, I have most common thing which we are using almost, that is this head, with which we can see the first 5 rows, right? So with the help of this you can see, can you see tenure, estimated salary, or has credit card, these fields? No, right? Because we have dropped these fields. Why xs equals to 1 is there and xs equal to 0 is also there? So why these two options are there, you all are going to tell me. Okay, so this thing we are too much familiar with, right? This is train test split. We have splitted the data into train test split because most of the things we have did now. Okay, visualization, cleaning, handling outliers, dropping the columns. Okay, those things we have did. Right, so now what we feel is we are going to split our data into train, test, split. And why it is needed, we know this thing, right? We have used this test in most of our models, right? Algorithms. So but there was one algorithm in which we didn't use this train, test, split. So which was that? Okay, you can drop the answers in the comments. Okay, so here what I have did is, you know what we did, right? Why we are just by reading this you can understand. Okay, drop columns exceeded, this is x field. Okay, that is why we are, means why in x field keeping all the things living exceeded column. Okay, we want rest of the things in x, right? Our feature. Okay, and y will be our exited, right? Because it is the target. Then test size, I have mentioned test size is 0.2. Okay, means 20% of our data is going to be for testing, right? Then random state, that is not much important. Okay, and this you will understand once we will go further. Okay, then here we know what shape does, right? It is going to give us the shape. Okay, means whatever the things are there, it is used, it is going to give us the figure, means number. Okay, so in training how much rows are being gone. Okay, so like that, and how much columns are there. So that is the thing where it is being showing over. See, 1, 2. You can see this credit score, geography, gender, age. Why this 7 is there? Okay, here only you can understand it. Credit score 1, geography 2, 3, 4, 5, 6 and 7. Till active members, means living exited. Here only we have mentioned, right? Top column exited, and so means living exited. These rest of the columns, it is going to be x. So x, train and shape of it. So total 7,711 rows it has took, means leaving them the 20% of data is going to be. Okay, and this much is our 80% of data, and in that how many columns it has took? It has took 7 columns. Leaving this exceeded, this rest of the columns are 7 columns. Okay, so it has took that for training. Okay, so why train, what it is going to be? 770. This same only it is going to be, right? Then for testing, as it is 20% of the data is good, it is going to take. Okay, so leaving these rows, rest of the it is going to be here, and 7 columns, of course it is going to take 7 columns. And for test, test, what it is going to do, it is going to do same thing, but this column is going to be, okay. So that is why this is how the train test split is splitted, okay. Y test value counts, and what is the value counts of 0 in Y test, and for 1 means stayed or churned, like that the count is there, okay. You can see the things like how many are there and how many are left, okay. So like that we can see from this also for testing, okay. So as we were converting categorical values into numeric one, those two fields were there in which there were categorical information, okay, that was gender and geography. So first we are going to convert this gender into numerical form, and we have two ways, okay. We have label encoder, one hot encoding, okay, for conversion of numerical into categorical into numeric, right. So for gender, what we are going to do is we will check first, okay, what is the count of it, count of gender, we will calculate it first, okay. So for male we have 5264, and for female in all we have 4375, right. We have seen this in the visualization also, that we will understand like which number is going to be high, right, maximum, okay. So for gender we are going to use label encoder, okay. So how this label encoder works, you all know, right, what it is for categorical to numerical conversion, right. In training data we have gender, okay. So we are going to give training data only, right. So we need to convert that, so that is why we have to training data, and that value counts we have took over here, okay. So we know on all how many value counts were there, but still we have took this, okay. So we need to fit that. What this fit transform does, we all know, we are very familiar with that, okay. So we have fitted those data of training data and testing data, okay. We have took that and we have transformed it, okay. Then gender, you can see this values are there, means like here you can see here it was male and as well as female, so here it is being converted, okay, it was transformed, okay. So one value is for male, and how many male values are there, you can see this much, same number it is going to be, right. And 0 means female, okay. So it has converted 1 for male and 0 for female, okay. So if we will again do this for checking, so you can see this gender, so you can see this only training data's gender is being converted, okay, because we need that only, right. We are going to pass that thing only to the machine. If you want to check, what we can do is we can just copy this thing, okay, and we can paste it over here and execute it. What the values, these are the row numbers, okay, that indexes or IDs, whatever you are going to say, okay, those things are there. And what are the values, 1 and 0s are there, okay. So this is how we have transformed or converted categorical values into numerical one, okay. So now what next one was there, it was geography, right. So we have to now transform that geography, and for geography we are going to use one hot encoding, okay. So in one hot encoding, what we do, we map the things. We know how many values are there in all, right, in our geography, right. So I have created here a function for that, okay. In that Spain I have mapped with 0, and France also I have mapped with 0, Germany with 1, okay. So like that I have did, okay, geography conversion, and then for training I am going to fit that data, okay. For training only I am going to take, okay, I am not going to take whole of the data, as like we did for this gender also, okay. We took for training data, we took the geography, in that value counts, how many values are there, the 0, and see it is converted, okay. For 0 it is going to be like Spain and France's values are being going to shown over here, and then 1 which is for Germany, these values we can see over here, okay. Its data type also we now know, it is an integer, right. First it was in object, right. Then next is testing purpose. So how many values are there in test? You can see in test it is not converted, okay. France is still there, Spain is still there, Germany is still there, okay. It is also 64, means like integer, okay, that is also in this only. Then for testing also we have used here, okay. For testing test data also in geography, okay, we have converted that thing also, okay. So now I am going to use the standard scaler, okay. But what the standard scaler is, it is pre-processing technique, okay. And what it does, it is used for standardizing the features of our data. So that is what I am going to use. And what it is going to do, it is trying to transform our data such that each column has mean is equals to 0 and standard deviation equals to 1, okay. So that is why I am going to use it. And here what it is going to do, this transformation, what it will do, it will result the features with 0 mean and unit variance, okay. Same it is going to do with this also. You can see the values over here also. if you want to check. So next we are going to use this mode. Okay, why it is, I'll tell you. But what this mode is, what it is doing, it stands for, first of all, it stands for synthetic minority over sampling technique. Okay, and it is popular technique. Okay, it is in machine learning, it is very popular technique. What it does, it is used to address class imbalance. Okay, if there is imbalance in our classes, yes, it was, right, and we know where it was. Okay, so that is why it is used. So this mode technique, it is going to give us this thing. You can see what it is doing. Okay, so that is why I have used this SMOTE. Okay, what it stands for, it is for synthetic minority over sampling technique. So this training data I have fitted in that. Okay, so you can see how the data is being divided now, how the imbalance is being handled, right? Here what we did, we have used the things and created all the things in level, right? So next what it is going to be, next we need to next what we are going to do is, we are going to choose the model. We are going to try different kinds of models, and then we are going to choose which one is going to be the final one. Okay, with which we are going to keep our results. Okay, so first model which I am going to use is logistic regression. Okay, the basic one which we have used first only. So some of the basic imports were there. Okay, decision tree also, random forest also. Okay, then these were some of the basic imports which I needed. Okay, so logistic regression is the main one. You're going to understand why I am taking, and the main thing which we need is accuracy. This is only going to tell us that which one model is giving us best accuracy, right? This number is going to be, and so overall in every model we are going to get this accuracy, and based on that we are going to take our decision. Okay, so here I have created this logistic regression. Okay, you can just copy this code snippet and then you can paste it. Okay, then this is there. Okay, so what is the main output we got? We got the accuracy like it is 0.72. okay, so we got this with the help of this logistic regression. Next we are going to use that these different what are the common things which we need for rest of the models also. Okay, so that things I have mentioned over here, means like created a list and that. Okay, so next here it is not proper logistic regression. Okay, the basic things which we needed that were there. Okay, so here the logistic regressions things which we need to give it to the logistic regression, those I have passed. Okay, grid search CV also in that. Okay, I have passed the things, so you can see what are the values which we have passed. Okay, logistic regression for the C value. Okay, random state, that is not much needed. Okay, so those things. So for training data I have created different one, and the predicted one, the output one, it is going to give us different. Okay, so we are going to get two different classification reports. Okay, so for training data means like whatever the training data is there for that what it has predicted. So classification report for training data, this is the report which we are getting. The accuracy you can see 0.68. okay, and for predicting means testing data, it has given us this report. So what this report is telling us, okay, in detail what it is telling us. So a precision value first for this training one. Okay, so for precision what we got means for class 0 means not churned one, for what we got 71%, 65% for churned one, right? So these values are in front of you. Okay, so class 1, its information. Okay, the model is better at recalling churned customers, means like 76% recall, than being precise, means 65%. Okay, this means that it's catching a lot of churners. Okay, but also predicting some non-churners as churners, right? Which type of it this is there in class confusion matrix? What it is said as? It is said as false positive values. Okay, precision. F1 score is 70%, right? Means it is solid. It shows the balance between precision and recall. And for class means 0 means not churned one. Okay, those customers which have not left are like precision is higher 71%, but recall it is low, right? 60%. What it means that the model misses many customers who stay, right? And overall accuracy, what it is 68% of accuracy. It is not very high but not too low also, right? Especially for imbalance classification task. The macro average, what it is telling us, this is just the unweighted average, okay, of the matrices for both classes. What it shows balanced performance across classes. This was for training one. Now let's understand what this testing classification report is telling us. The values are in front of your, okay, you all, right? So class 1, for class 1 means churned customers. What it is, high recall value is there, right? 79%, right? So model is catching most of the churners, and as well as it is having low precision, means like 34 only, okay? So many false positive, that is customers are incorrectly flagged as churners, right? 34%, right? But is it better than testing data? You have to tell me, okay? F1 score is of 48%, right? That indicates an imbalance between how many it catches and how many it gets right. And for class 0 means like not churned, what it is very high precision, 92%. When it says someone won't, it's usually right, but it misses many actual non-choices, means because recall is 61% only. Its accuracy, what's the accuracy of it? It's 65%, similar to training, right? Means what it is suggesting, no overfitting, but model still needs room for improvement. It has not given us two good results, okay? So we have to try different models also, and if they are also showing less performance from this, then we are going to go with this model only, okay? So macro average, what it is 0.63 precision, 0.70 recall. So what it is telling us, it slightly favors class 1 due to its high recall, and what its weighted average, heavily influenced by class 0 due to higher support, right? More data points are there in that, okay? So what is overall interpretation of this report? Its strengths are like this model does a good job detecting churn customers, right? Means high recall because of that, and which is essential in churn prediction, okay? So we might go with this model also, okay? It performs similarly on train and test data, right? Generalizes, it is generalizing decently. But what's the weakness of this? Low precision for churn, means many false alarms are there. Not ideal if actions on churn predictions are costly, okay? And accuracy 65 to 68%, means it is moderate, okay? Common for churn data set, but could be improved also. So after finishing this classification report of prediction as well as training data, we have understood what are the things which it is giving, how much percent of accuracy we are getting from this data, okay? Now what we do is we are going to try more different models, okay? So we know what classification different models are there, right? So that, and what kind of answer we are getting, so based on that we are going to use next model, okay? So here what it is, XGBoost, okay, and light GBM, okay? So these things I'm going to install, okay? We require that also, means like I'm going to use those models also. Then some of the things from scikit-learn I wanted, okay? This is, we know what it is, right? So that, then random forest also I have took, and gradient boosting classifier also. These things you all are familiar, we have covered most of the theory, right? These XGBoost and light GBM, these all are also different models, okay? These we have not looked had a look in depth, okay, at them, but still we will see how they are working, okay? We need to pass same things only for them also. So here I have created for the random forest classifier. And random forest classifier, what is this? N estimators, that means these are 100 different trees, okay? The like that it is there, okay? So like that. Then entropy, what is it? Gini, how it means what these two parameters are for, that also we have learned, okay? Then max depth means how much trees, or how much leaves it is going to, how much leaves it is going to go in depth, like that we know, okay? With this minimum sample leaf, now what is leaf, okay, and what it is going to do, split. These we have seen what random forest is, okay? And for random forest these things are important, okay? So that is why these parameters we have passed for that, okay? For grid search CV, okay, these things were required and that we have passed it, okay? You can just use these things and then you can pass. Then what it is, we have passed those data into training and testing, not just not for testing but for training, okay? So xtrain and ytrain, we have passed that data into this. Then best estimator means like how many number of trees it is going to be. So here the random forest classifier we have used, and what are the description for it, means like maximum depth is what, how much depth it is going to go, then sample leaves, okay, minimum sample leaves and minimum split, what they are going to be, that it has told us, okay? Means that it is going to stop. And for stop we know what is pruning, right? You remember what we learnt about pruning in our previous videos, okay? So if you remember that, then you will understand the things, okay? Then best params, okay, means whatever the things were there for it, for the random forest classifier. Those things are mentioned over here. Okay, we can understand with this also that how the tree might look. Okay, we are not going to view here decision tree. Okay, and then what we have done is we have used that training data. Okay, training data. For that training data we are going to predict classification report. Okay, and then for prediction also we are going to print classification report. This random forest, whenever you are using this random forest and you are passing all the things, okay, to it might take a bit of time. Okay, it might take longer than other models because it needs time. Okay, it needs time to make predictions. Okay, to form that tree. Okay, so it will take a little bit of time, so don't panic for that. Okay, and yeah, because I have already executed this, that is why it is showing us. Okay, that is why there is no problem in it, but it took time. Okay, it took at least 5 minutes of time. Okay, it's based on your systems also sometimes. Okay, then for this is for training datas. Okay, this classification report is of training data and this is of prediction. Okay, testing, after testing what we got, and after on training data what we got, the results. Okay, you can see what is there. Okay, now let's understand these reports in detail. So we know we have class 0 and class 1. What is class 0? Means they are not churned. Okay, they are staying in that company, bank. Okay, and they are class 1 means they are churned. Okay, they have left the bank services. Okay, so let's understand for class 1, for churned customers. Okay, in this report for the training data. Okay, we are looking at training data now. Okay, we got recall value. What we got recall value for churn. Okay, for not churn means like 0. Okay, so for churn customer, for look at this one. Okay, this one values. For that what recall we got? We got recall 79%, right? So model is catching most churners. Okay, about precision, what it happens? We have got 34, means like precision is low. Okay, 34%. Many false positive, that is customers are incorrectly flagged as churned one. Okay, and F1 score, what it is? F1 score, you can see that. Okay, it indicates an imbalance between how many it catches and how many it gets right. Okay, now for class 0, very high precision we are getting, right? What is the what is the precision value? We have got very high precision. When it says someone won't churn, it's usually right. Okay, and for class 0, what are the values? We have got very high precision value. Okay, when it says some customers are leaving, then it is right, but it misses many actual non-churners also. Okay, what is accuracy? You can also see macro average. Okay, what values we have got, what is weighted average. Okay, it is heavily influenced by class 0. Okay, so by looking at this also you can understand what is for training and what is for testing, what values we have got. You can see what accuracy here we have got and what accuracy we have got here. Means there is no most, so there might be the thing that there is no overfitting and there is no underfitting also. Okay, because we are getting most of the things similar only. Okay, then what is the precision value for churned one and not churned one, right? Then macro average, weighted average, what these values tell us, we can understand for this test data also. Okay, what accuracy we are getting? 81%. Okay, so this is the thing that we are getting over with this. Then what is precision value? What with the help of this F1 score you can understand the balance, right? So most of the things you can understand with this classification report. This is for random forest classifier. Okay, what the main important thing, the main important matrix would be this accuracy, and this is too good. Okay, this is not too bad, but it is okay, and it is good than this model, right? Which one was our previous model? Logistic regression. It is better than this. Okay, so you can understand by the values only, right? What are the precision, recall, F1, those values. By looking at those values only you can understand that this model is bit better than the logistic regression one, right? So same things we have applied, but here we have used we have used gradient boosting classifier. Okay, so here whatever the things which were needed for gradient boosting, we have placed those things. Okay, n estimators, what are there? Okay, then samples, subsamples, learning rate, means whatever the things which are needed for this model, we have passed the things over here. Okay, then grid search, CV also, for that also we have passed the things. Okay, the main important thing which is this one. Okay, this what you can understand from this. Now you all are at that level that you all can understand, right? With looking at the example, with looking at the model, what are the descriptions, what is printed on that you can understand. Okay, So these things are there. Then we have given this data for training. Okay, with training we need to fit the 80% of the data, right? So we have given that data to the training, and for training we have got this classification report, and for test data we have got this classification report. Okay, so let's understand this classification report in depth. Okay, so for classification report for this training data, what we have got, what is the accuracy we have got, that is 83. Okay, balanced performance, okay, across classes. This model treats both churners and non-churners equally well, right? What is F1 score? F1 score, it is also 83% only, right? For both classes, at that it F1 score is same for both the classes, right? For churn also and for non-churners also, it is 83 only. So it is what it is indicating, that it indicates a strong model. Okay, this is a strong model that it is indicating. Okay, so there are no results of overfitting, no signs of overfitting. Okay, test results are slightly lower, but okay, so let's see what this test results are also telling. Okay, class 0, for what is this of class 0? Okay, excellent performance. Okay, especially when it is coming for precision. Okay, you can see this with this numbers also. Very few false positives are there, right? Then class 1, for class 1 what it is? Recall, it is 73%, right? Model catches 73% of actual churners. Precision, it is 54, right? Only a bit better than random guessing. Lots of false alarms are there. Okay, F1 score, what is F1 score? It is 62%, right? Slightly better than random forest. Okay, so these things are there present. Okay, so overall, by looking at these three reports, what we get is overall summary. If we see, okay, so gradient boosting classifier is currently our best performing model. Okay, accuracy is also 82%. Okay, good recall for churn, that is 73%, still important for retention strategy, but okay, and improved churn's precision. Okay, 54 percentage is there, and we need to improve that, better than both previous models, right? So there's still room to improve churn precision, but it's a great balance between catching actual churners and minimizing false alarms, right? So overall, which, by understanding these report, which model are you are going to go with? Okay, this is our fully machine learning project. Okay, machine learning classification project. Okay, so these three reports, based on three reports only, we are going to go with these models further, and then next things comes for the ML engineers or them. Then we need to save these files into different files. Different files means like pickle file is there, as well as joblib is also there. Okay, we are then saving these things into those files. Okay, whichever model we are going to take based on these reports. Okay, we can see the reports, and then by looking at that we can understand if there is overfitting, if there is need of improvement, and like those things we will discuss. Okay, but for right now I think this gradient boosting classifier is okay. Okay, because it is giving the, on testing data it is giving nice results. Okay, that is important, right? Because on unseen data it is giving good, but we need to improve for this. Okay, for churners, this thing we need to improve, then everything rest of the thing is good. It is 82%, this model is good, so that is why we can go with this. If you will go for the random forest one, okay, here it is giving 81%. Okay, this is also okay, but you can see on testing data we need important thing, and that is why we are going to go with this model. Okay, so once we get the model, what our next thing is, we need to, according to the requirement, according to the deployment requirements, we need to convert our files. Means like pickle file is there, joblib is there, whatever the front person's need is there, it is going to be converted in that. Okay, and then we have to pass those files, then the deployment process is of next. So this is a whole project of machine learning classification project. Okay, with this you can understand that which model to go with, and then we can understand that how many customers are living, how many customers are staying, using bank services. Okay, with those things we can understand. Okay, and there you have it. We just built a full machine learning model to predict banking customers churn. If you coded along, you just added a real world project to your data science journey. Got questions, suggestions, or just want to sip tea and nerd about machine learning or anything under the sun? Drop a comment. I'll gladly read them all, and I'd love to hear from you. Don't forget to like, subscribe, and turn that notification bell so you don't miss more practical job ready projects. Until next time, keep learning, stay curious, and remember, real skills, real impact. Let's make the data dance.